Good morning, good morning, good morning. Good morning, good morning, good morning. Good morning. We're just going to wait about 2 minutes for more people to join. Give it about a minute and a half. Good morning, good morning, good morning. I'm going to give it about 1 more minute and then we're going to get started. I'm still waiting for some people to join in. I don't know where my usual crew is. We're going to start promptly at 10. We are on week 4, day 4. All right, it's 10 o'clock, so I want to make sure we're using our time wisely. We are on week 4, day 4. This is the first page of that packet right here. Before I dive in today, I just want to give you guys an update on grading. Term 3 grades go in Friday. I am still grading because I just learned that I have to go up to the school to pick up some more work. So I will let you guys know when your grades are up in Aspen. I anticipate it being sometime on Friday. So with that in mind, let's just get started. And as you guys join in, please chime in with answers to questions. So week 4, day 4, our objective is that by the end of today's lesson, you will be able to explain the concept of balance point to a family member, and you will understand why the balance point is always the mean, even when the mean is not the best typical value for a data set. Okay? So, week 4, day 4, here is our first question. It says, consider the numbers 1 and 5. What is the mean of the numbers? Now remember, to find mean, we're going to add our two numbers together and then divide by 2. So 1 plus 5 is 6 divided by 2. 6 divided by 2 is 3. So, I don't know why it just did that. Hold on 1 second, let me clear that out. So, when I look at the means of 1 and 5, my mean is 3. So now they gave us this diagram. And on this diagram, they plotted 1, 5, and then the mean that we calculated was 3. So they're asking us, what do you notice about the distance between each of the original values and the mean you just calculated? So what I notice is that when I look at 1 and our mean 3, it's 1, 2 places away. And then when I look at 5 compared to our mean, which was 3, it's also 1, 2 numbers away. So the answer I would write right here is that each value, and I'm going to put in parentheses 1 and 5 because those are the values I'm talking about. Each value is 2 units away from the mean. Okay? So 1, 5, each of them are 2 values away from the mean. So now let's look at 3 and 11. When I look at 3 and 11, I need to find my mean. So I'm going to do it the same way I did it above. I'm going to do 3 plus 11 over 2. 3 plus 11 is 14 over 2. 14 divided by 2 is 7. Okay? So those of you that are joining, we're on week 4, day 4. We just started. We're on question number 3. So the mean of 3 and 11 is 7. All right. So it says mark these numbers and their mean on our number line below. So I need to plot 3 and 11. So I'm going to come to 3. I'm going to put a dot right there. And then I'm going to come to 11 and put a dot right there. And then it says our mean is 7. So I'm going to come put a line right here. And the reason I'm putting a line is because remember how we talked yesterday about how mean represents the middle? So I'm going to use this line to show that this is our mean, which we said was 7, which is the middle of our data set. Okay? Then it says, good morning, good morning. Then it says, what do you notice about the distance between each of the original values and the mean you just calculated? So remember, our original values were 3 and 11. So here's 3 and here's 11. And now we have to find out how far away they are from our mean. So I know that this distance right here is 1, 2, 3, 4 units. And then this distance right here is 1, 2, 3, 4 units. Okay? So what do I notice? I notice that each value, and in parentheses, I'm going to put 3 and 11 because those were our original values, is 4 units away from the mean. And in parentheses, I'm going to put that our mean was 7. Okay? All right, so let's keep going. Now we're on page 28, week 4, day 4. It says, now consider the numbers 2, 3, 5, and 6. What is the mean of these numbers? Now, remember yesterday that when we had data sets that had more than 2 numbers, the way we would find the mean is by starting at the beginning and starting at the end and crossing out numbers until we ended up with a number in the middle. But if you notice, if we were to do that, we have 2 numbers in the middle, 3 and 5. So to find the mean, we're going to take these 2 numbers, we're going to add them together, and then we're going to divide by 2. So 3 plus 5, we know is 8 over 2. And 8 divided by 2 is what? Can y'all drop that in the comments for me? 8 divided by 2 is... 8 divided by 2. Oh, come on, guys. This is a simple one. 8 divided by 2. 4. There we go. Yes, 8 divided by 2. Oh, got my 4s. Thank you, guys. 8 divided by 2 is 4. So when we look at the data set 2, 3, 5, and 6, our mean, or our middle, is 4. So now it says, look at the diagram to the right. This is the diagram we're going to be working on. What do you notice about the distance between each of the original values and the mean you just calculated? Okay, so our original data is 2, 3, 5, and 6. Now it's asking us if our mean is 4, what do we notice about the distance from each of our data points to the mean? Okay, so let's start with 2 and 6. So the values of 2 and 6 are each 1, 2 units away from the mean. So just to review what I did, I took my 2 data points on the outside and I calculated how far they were away from our mean. And I got that both 2 and 6 were 2 units away from our mean. All right, so now let's look at 3 and 5. So I'm going to write the values of 3 and 5. Now, 3 and 5, they're each 1 unit away from our mean. So the values of 3 and 5 are 1 unit away from the mean. Okay? So that's what these arrows up here are showing. These arrows up here are showing that when I look at 2 and 6, they're both 2 units away. And when I look at 3 and 5, they're both 1 unit away from the mean. Okay. So let's keep going. So what do you notice about the sum of the distance between the mean and the numbers below the mean, as well as the sum of the distances between the mean and the numbers above the mean? Okay? So what that's saying is when I come back to this line up here, I know that 2 and 2 is 2 units away from our mean. And I know that 3 is 1 unit away from our mean. Okay? So, it actually has the answer right here. So what you notice is that they're both equal to 3. So 2 is 2 units away. And then 3 is 1 unit away. Okay? If I add these together, it gives me 3 units total. All right, now let's do the same to the other side. 6 is 2 units away. 5 is 1 unit away. If I add these together, I get 3 units total. Okay, so the total units away from the mean is equal on both sides. All right, so let's keep going. So now we are going to consider one more example. So now they're asking us what is the mean of a data set that has 2, 3, 6, and 9 in it. Let me straighten out my paper. So remember, here's how we find the mean. We start at the beginning and the end, and we move in until we are either down to 1 or 2 numbers. So here in this case, we're down to 2 numbers. So we're going to take these 2 numbers in the middle, we're going to add them together, and divide by 2. So 3 plus 6 is 9 over 2. 9 over 2 is 4.5. Okay, sorry guys. My brain just drew a blank there for a second. So now it's saying, look at the diagram to the right. What do you notice about the distance between each of the original values and the mean you just calculated? So I don't know why they say our mean is 5. Because our mean should actually be 4.5, because 3 plus 6 is 9. 9 divided by 2 is 4.5. But we're just going to run with their example, and we're going to say that the mean is 5. Okay? So if the mean is 5, okay, the value of 2 is 1, 2, 3 units from the mean. Okay. And then if I look at 3, is 2 units from the mean. Now we have 2 more data points. 6, all right, the value of 6 is 1 unit from the mean. And then 9, which is our last data point, I'm going to write over here. The value of 9 is 4 units from the mean. Okay? So, as you notice, every value in our data point, in our data set, is a different distance away from the mean. But here's where it gets interesting. Okay? Now they're asking us to consider our data points below our mean. So our data points below our mean are 2 and 3. And to find the distance of those data points from the mean compared to the distance of our data points above the mean. So what that means. So I'm going to write below mean. All right. So if I'm looking at our data set below the mean, 2 is, we said, 3 units away. All right. And then we had 3, which we said was 2 units away. Now, just like we did up here, we are going to add these together. Okay, so I'm going to add these together, which gives me 5 units total. Okay, so now let's look at above the mean. All right. So our 2 data points above the mean are 6 and 9. All right. So we said 6 is 1 unit away. Okay. And then we said 9. We said that was 4 units away. Okay. So just like we did over here, we're going to add these together and we get 5 units total. So what this is showing you is that we can say that 5 is the true mean for this data, because when we look at the total distance from the mean to our data points below and above the mean, they're equal. Okay, they're equal. And just to remind you how I got this value, I took the distance that each value was away from the mean and I added them together. All right. So here is the important point right here that you guys need to be aware of. I'm going to star it so you guys know to come back to it. Oh, excuse me. The sum of the distance between each number below the mean and the mean itself equals the sum of the distances between each number above the mean and the mean. This is why we call the mean the balance point. So you guys know a balance like a scale. In order for a scale to be balanced, the weight on both sides has to be equal. See how they're equal? Since they're equal, we know that this data set is balanced. So that is the point of our balance point. Okay. So notice the individual distances are not required to be the same. On the number line above, the distances below the mean are 2 and 3, while the distances above the mean are 1 and 4. As long as the sums are the same, you have the correctly identified balance point. So I am going to highlight this important information for you guys. First, you need to know what balance point is, and then you need to know this right here. Okay. And this right here pretty much is just putting in words what we did right here. All right, so let's keep going. Okay, so we have a data set. 25 sophomores participated in the school walkathon. So this should sound familiar to you guys because we've done this before. 25 sophomores participated in the school walkathon and reported their results. The dot plot is shown below. So what we see that 1, 2, 3, 4, 5, 6, 7, 8 students walked 1 mile. I then see that 1, 2, 3, 4, 5 students walked 2 miles. Then I see that 1, 2, 3, 4, 5 students walked 9 miles. And then I see that 1, 2, 3, 4, 5, 6, 7 students walked 10 miles. Okay? All right. So, it says, what is the balance point? So what is the balance point of the sophomore data distribution? Okay, so remember, our balance point is that data point where everything below and above are equal. So here's what I want you to think of. If 25 sophomores participated, 25 is an even number. It's an odd number. Okay, so we have to find the middle point. All right. Now, I know that when I look at 25, okay, as we said, it's an odd number, which means we are going to have one true data point in the middle. So I know the middle value is going to be the 13th data point. Okay? And the reason I know that is because if I start at 1, I count up to 12. Then I have 13. And then if I start at 14 and I count 12 more, I'm going to get it 25. So I know, so this is 12 here. This is 12 here, 13. The 13th data point is my true center, okay? So I need to come back up here to my data, and I need to find the 13th data point. And here's how you do that. You just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, okay? Hold on, guys. Sorry, I just want to make sure I'm explaining this correctly. Okay. So, I'm actually going to take a step back. We're going to pause on this information right here because this information actually goes with this question down here. So we're going to pause on this information. So what it means by balance point. Okay. So we need to find the center of this. And what they mean by finding the center is, if I look at this graph, it's kind of shaped like a U. Okay? My data starts off high, goes down low, goes back up high. So when it's asking me for my balance point, it's asking me, if I look at this curve, where will I hit my lowest point? And that would be 5. So our balance point would be 5. And the reason our balance point is 5 is because if I was to take this graph and chop it in half so it was equal, that's what around what I would get. So now, it says calculate the median of the sophomore data distribution. Remember this explanation I gave up here? It goes more with this question right here. So we're looking for the 13th data point to give us our median. And so all I got to do, like I explained previously, is count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 8, 9, 10, 11, 12, 13. So this right here is my 13th data point. My 13th data point is 2. So my median would equal 2. And I'm going to put in parentheses because it is the 13th data point. Okay? All right. So, is this distribution symmetrical or skewed? So, we've been learning about left skewed, right skewed, symmetrical since the start of week 4. So, this would actually be a symmetrical distribution. And the reason it's a symmetrical distribution is because when we look up here, it still gives us a nice U shape where the data on one side pretty much equals the data on another side. All right. So let's keep going. I want to get as much done with you guys as I can. So, all right. So is the balance point the same as the typical value for this distribution? Explain. So, see how we have this U shape right here? Because of this U shape, what that means is neither the mean, which remember is our average, or the median, which is the middle, are typical values. Okay? And the reason for this is because of the U shape. Okay? So what that means is when you guys come back to this, because we have data points that are really low compared to data points that are really high, when we calculate our mean and our median, we're going to get a value that's somewhere in the middle. And since we have no data points in the middle, to have a mean or a median in the middle doesn't make sense. Okay? All right, so let's keep going. I'm hoping to finish this day before time's up, but we'll see. All right, so 22 students from the junior class and 20 22 students from the junior class and 26 students from the senior class at River City High School also participated in the walkathon. Okay? Dot plots indicating the distance in miles students for each class walk are shown as follows. So here's for the juniors. Here's our data distribution for that walkathon. And for our seniors, here's the data distribution for that walkathon. So what is the median of the junior data distribution? Okay? So the juniors had 22 students participate. Okay? Now, remember, when you have an even number, you're going to have to look at 2 data points and find the difference between them. So 22 divided by 2 is 11. So what that means is I need to find the 11th and the 12th data point and find the middle between them. So let's start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my 11th data point is 8, and my 12th data point is 9. Okay? So what I'm going to do with these two numbers to find our median is I'm going to add them together and divide by 2. So 8 plus 9 is 17 divided by 2. This is going to give me 8.5. Okay? So our median is 8.5. Okay? And I'm just going to make a note to remind us that this is halfway between the 11th and 12th data point. Okay? All right, so the next question says, is the mean number of miles walked by juniors, so I'm just going to make a note that our mean, we said, was 8.5, is the mean number of miles walked by juniors less than, approximately equal to, or greater than the median number of miles? If they are different, explain why. If they are approximately the same, explain why. All right. So, in order to understand this question, we have to look at this graph right here. All right. Now, what this graph shows me is I have most of my data points at 8, 9, and 10. Okay? And then I have a few at 1, 2, 3, and 4. Okay? Now, even though I have a lot of data points here, these data points are still going to affect my mean, which is our average. Okay? So, when it comes to this question, is the mean number of miles walked by juniors less than, approximately equal to, or greater than the median number of miles? Explain. So, the mean will be less than the median, which we said our median was 8.5, because our low data points, okay, so our low data points, I'm going to put in parentheses that we're talking about our 1s, 2s, 3s, and 4, will pull the mean, and just to remind you guys, that's our average, below the median. Okay, so that's why in data sets, we might sometimes call these outliers, because these outliers have a negative effect on these data points over here. And the negative data effect that they're going to have is they're going to pull down our average data. Okay, and sometimes pulling down our average data isn't a good thing. All right, so what would you say is the typical number of miles walked by a junior in this walkathon? Okay, so what this is saying is, let's come back to our graph. It always comes back to the graph. And like we said, most of our students walked 8, 9, or 10 miles. Okay? But we still have these little ones right here. So what's the typical number of miles walked by a junior in this walkathon? We would say the typical number of miles walked is around 8.5, which is our median, because this represents the high numbers walked as well as the low numbers walked. Okay. All right, so what is the balance point for the number of miles walked by a junior in this walkathon? Okay. So the easiest way to find the balance point the reason I'm struggling with the answer is because the way they explain balance point to you is not the way they are anticipating you to answer it in this question. Okay? Because the way they're anticipating for you to answer it in this question is that the balance point is equal to our mean, which we've been talking about as average. But the way we were talking about the balance point earlier is where you look at your median, and then based on your median, you add the distance up. So I'm just trying to find the best way to explain their answer to you. So we said our median. Okay. All right, so what's the balance point? I'm going to say our balance point is 7. Okay. It's approximately 7 miles because what we would find out is that if we sat here and actually calculated out the average of all these data points, we would get 7. Okay. So if we were to calculate the mean of all those data points, we would get approximately 7. So that's why they're saying it's the balance point. All right, so question number 9. What is the median of our senior data? So now we're going to look at our senior data. Remember, 26 students, from our senior class participated. So 26 divided by 2 is 13. Okay, so I need to find the middle point between our 13th data point and our 14th data point. All right, so let's start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 is 7. 14 is 7. So 7 plus 7 over 2 is 14 over 2, which equals 7. So what's the median of the data distribution? It would be 7 miles. Okay, so estimate the mean and the median of the miles walked by the seniors, okay? So we already said our median is 7 miles. Is your estimate of the mean number of miles less than, approximately equal to, or greater than the median number of miles walked by the seniors? Okay, so let's come back to our graph. All right, now you guys should notice something about the distribution of this graph, and that it is symmetrical. Okay, so what that means is I should be able to say this data point and this data point kind of cross each other out. This data point and this data point kind of cross each other out. This data point and this data point kind of cross each other out. So when I'm left with 3 data points, I notice that 6 has my most data points in it. So I know that if I do, so what I'm going to do, these two will say cancel each other out, but because there's more data points on 6, I know that my mean is somewhere in here. I know my mean is between 6 or 7, okay? So let's say my mean would be between 6 and 7. So my mean would be between 6 and 7. My median is 7. So my values for mean and median are approximately the same because of the symmetrical distribution of the data. Okay? All right, so what I'm going to do is I'm going to pause. I'm going to drop our attendance code word in. So our attendance code word is going to be raining. Okay. So that's our attendance code word. To get credit for attending today's live, make sure you DM me our code word. I'm going to keep going until 10:45 because I want to get as much of this done as I can before I have you do some on your own. So let's keep going. All right. How would you describe the typical number of miles walked by a senior in this walkathon? Okay. So because we have symmetrical data, because our mean and our median are approximately the same, I can say the typical number of miles walked is around 7. And I can say that because our data is symmetrical and our mean and our median are about the same. All right. So what is the balance point for the number of miles walked between a junior and the walkathon? So I want you guys to remember that balance point equals our mean. Back in this problem, we said our mean was between 6 and 7. So our balance point would be between 6 and 7. Now, if I wanted to find our true balance point, I would actually have to sit down with our data set and calculate the mean. But since we're just doing an approximation based off our data distribution, I would say our mean or our balance point would be between 6 and 7. All right. So a junior from River City High School indicated that the numbers of miles walked by a typical junior was better than the number of miles walked by a typical senior. Do you agree or disagree? All right. So, do we agree? Did the junior class do a better job of walking than the senior class? So, remember, our typical number of miles walked is equal to our median. So remember, the median for our junior class was 8.5, but the median for our senior class was 7. So, a junior, so I'm just going to make a note, median for juniors was 8.5. The median for seniors was 7. Okay? So, yes, he is correct because the median for the junior class is higher. Okay? So, now it's saying, look at your answer to the question above. How could you estimate the balance point from the dot plot? How could you estimate the median? All right. So, this question is asking us to compare two types of data distribution. Symmetrical and skewed. Okay, so to help you remember, our juniors were skewed, had that data trend, but our seniors was symmetrical. Okay? So when I'm looking at symmetrical data, the middle of the dot plot would approximate the mean and locate the median. Okay, so what this means is when we have a symmetrical data distribution, our mean and our median are most likely going to be towards the middle. However, if our data is skewed, after we find the median, okay, we would move towards the tail of the data distribution to find the mean. Okay, so if data skewed, we would find the median, just like we've been finding the median, and then we would move towards the tail of the data distribution to find the mean. So what does this mean? So if we look at this data distribution right here, it is skewed, okay? We have more data on the right than we do on the left. We said our median was 8.5, which is about here, okay? Now, in order to find our mean, we are gonna have to move this way on our number line until we find that mean. And the reason for that is because these lower data points pull down our mean. Okay? So guys, this is where we are going to pause for today. Page 33 and 34, you are going to complete on your own. All right, now, before I sign off, just a few reminders. I am still working on term 3 grades. I'm actually about to run up to the school to pick up the remaining packets so I can get those graded and put into Aspen. I'm hoping to have your grades up by Friday. I will post on my Instagram feed when your grades are up. Also, please keep in mind, term 4 does count. I am expecting to get work from you for term 4. All right. If you guys have any questions, you need any help, please feel free to drop me a DM, send me a comment, send me an email, whatever works for you guys. Okay. I am here to help you. If there's nothing else for the good of the group, I'm going to go ahead and sign off for today. Please don't forget to send me our attendance code word so you get credit for attending today's live. I'll see you guys next week. I hope you have a great rest of your week. Bye, everyone.